Hello. So continuing on this weekly contest, 321, the second problem, which is append characters to make string, to make subsequence. So what this problem asks us to do is that we get two strings, right? We get S and T. And what we want to do is, they both have only lowercase English letters, and we want to return the min number of characters that we need to append to the end of S, right? So that T becomes a subsequence, right? And subsequence basically means it's part of the string and in order, but it's you can skip some letters, right? So for example, here co-n, for example, let's say con, it's a subsequence of coaching, right? So that's the idea. Now let's take a look at the first example here. So we have coaching is S and coding is T. So you can see that we have a match here with co at the beginning, but we don't have a match for the rest, ding, right? We have E and G, but there is no D before. We can't put something in between. The only operations we can do is append to the end of S, right? So we have to append ding so that we can get coding. And what is the length of ding? That's 4. So we return 4. For the second example here, we have A, B, C, D, E, right? So A is already there, so we don't need to do anything, so we return 0. For this example, T, A, B, C, D, E, it's no letter is in S, so we have to append the entire thing, which has length 5. So pretty much that's the idea. It's 10 to the power of 5, so that rules out definitely like doing an event square thing. So let's see how we can solve it. It's actually very straightforward because all we need to do is traverse coaching, right? Because if we traverse coaching like this here, then we can, so if we traverse coaching, let's say, and T is equal to this, right? And S is equal to this. So we can just traverse coaching. So C, maybe using a pointer here. So let's say we traverse S with character, so C. And let's say pointer here, call it maybe I equal to 0, right? So it starts out at 0. We compare. If they are equal, we move I. So we increment. So if basically C is equal to TI, right, we increment I plus 1. Because that's what we are looking for. We want to get as much subsequence as we can, right? Because we want to minimize how many we add to the end of S. So as many equal things as we can, we want to get them, right? And so we increment I again, right? So now I is equal to, so first 1 and then now equal to 2. And then we are here for C. Now we don't find any match anymore, so we don't increment I. No match here at D, so we increment. No match again, no match again, and no match again, and no match again, right? Until the end, right? And once we are done, how do we get the length of what we need to append, which is 4 letters here? Well, it's just what's remaining, right? And how do we calculate what's remaining of T? It's just the length of T, right, minus where I is at, right? So minus I, and that would be what we need to return at the end. Okay. Maybe let's see if we can check if this works for other cases. Let's say the one where we had Z and we have T is equal maybe to A, B, C, D, E. So yeah, that would work because I is first here, C is here. No match, so we move C, and now we are done for S, and now we just return the length of T minus I, which is equal to 0 because we didn't advance it, so it's the length of T, so it's the entire thing. So that works. So pretty much that, and it makes sense because we are allowed to do a subsequence. So let's say maybe we had D here for this example, right? Then what we will do is we will move C, and we are here, no match, and we move again, no match, and now we have a match at D, so we increment I like we did here, and we have a match again, so we increment I again, and we keep going, and because we still have match, and now we are done, and now we are done here, and I is equal to the length of t. And so length of t minus length of t is equal to 0, and that works because we found the match, right? So that's pretty much the idea. Yeah, so pretty straightforward solution. So let's just do it. So we need to initialize I, and then we need to go through for C in S. We need to check, as we said here, we just check if there is a match. So we check if C is equal to the element we are looking at in T. So if it is, we increment our I pointer, and then at the end we want to return the length of T minus I, right? Now the only thing we need to be careful of is, what if we find a match? Let's say maybe we have S is equal to code every day or something like that, and then T is equal to code, right? So if we do that, then we would do S move until here, right, for C, and then for I we move, because we keep finding a match, we find the match for the entire thing, but we are done. And so when we do this here, right, I is done, it's out of the bounds, so we don't want to increment it anymore, right? We don't want to get a negative number here, right? So we just need to safeguard against that and make sure that the length of I is smaller than T. That I is smaller than the length of T, because otherwise there is no need to increment, because we found our match, and so we return 0, right? Yeah, so that's pretty much it here actually. Let's run this and submit, and that passes, right? Now in terms of time complexity, we are just doing one loop of n being the length of S. That's pretty much it, and we are not using any extra space really. So it's O of n time and O of 1 space. Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.